In this video, we're going to take a look at some additional examples of simplifying trig expressions. In this example, we're going to simplify cosecant x minus cosine x times the cotangent x. Since we don't have any trig functions squared or any other sort of unusual thing happening here, the only real strategy we have to approach this problem is to write everything in terms of sines and cosines. We know that cosecant x is 1 over the sine of x, and we know that the cotangent of x is the cosine of x over the sine of x. And so we can make both of those substitutions using reciprocal identities. And now we see that we actually have a common denominator here. We have 1 over sine x, and the second term we can multiply together here to get cosine squared of x all over sine x. We're now subtracting two fractional expressions with a common denominator, so this becomes 1 minus cosine squared of x all over sine of x. And 1 minus cosine squared of x is another way to write the sine squared of x. All right, this is just the standard Pythagorean identity, which is cosine squared plus sine squared equals 1. Solved for sine squared of x, so subtracting cosine squared from both sides of this equation. So we see we get a cosine of x, sine squared of x here. And sine squared of x divided by sine of x leaves just a single power of sine x here. And so our expression cosecant x minus cosine x cotangent x simplifies simply to sine of x. In this example, we want to simplify the tangent of theta times the sine of theta plus secant theta plus cosine squared of theta. Again, we don't have anything squared, so there's no obvious way to use a Pythagorean identity. And so the most natural thing to try here is to write everything in terms of sines and cosines and simplify from there. So here we have a tangent of theta, which we know is sine theta divided by cosine theta, and that's just multiplied by sine theta. We know that 1 over, or secant theta is 1 over cosine theta, and that's multiplied by cosine squared theta. Now you might look over here and see we have 1 over cosine times cosine squared, and think that maybe we want to multiply that together to form just cosine of theta to have some cancellation there. But in fact, it's actually a bit easier if we instead notice that we have a common denominator of cosine theta for each of these expressions. And so when we combine each of the terms here, we have sine over cosine times sine becomes sine squared of theta over cosine of theta. And on the second term here, we actually end up with cosine squared theta over cosine theta. And despite the fact that that is not simplified, it actually is helpful because we have this common denominator, and so we can actually add these expressions together. And so what we have is sine squared theta plus cosine squared theta all over cosine theta. And the numerator here we know is 1, and so we obtain 1 over cosine theta, which is equal to secant theta. And so our expression here that we started with, tangent theta sine theta plus secant theta cosine squared theta, simplifies to the secant of theta. For our final example, let's simplify the cotangent of z times the tangent of z plus the cotangent squared of z. We might approach this the same as the previous two examples by replacing everything with sines and cosines, but if you did that, you'll notice that we actually get some complicated expressions and a lot of cancellation. It turns out that this one, because of the cotangent squared, can be done much more simply than if we converted everything to sine and cosine. So for example, we might notice right away that cotangent and tangent are reciprocals of each other. So cotangent of z is the same thing as 1 over tangent of z. And so we get a nice cancellation there, and we're left with just 1 in that first term. So we're left with 1 plus cotangent squared of z. Now this expression should probably look familiar. This is actually equal to the cosecant of squared of z via the standard the Pythagorean identity. If we had forgotten about this, we can always remember that sine squared of z plus cosine squared of z is equal to 1. And if we divide everything here by sine squared of z, term by term, we get the identity that 1 plus cosine squared over sine squared is the cotangent squared, and 1 over the sine squared is the cosecant squared. And so we get exactly the identity here. And so this, using this approach, this simplification is quite easy. We can cancel the cotangent and tangent to become 1, and then simply use the Pythagorean identity to get to the simplification of cosecant squared. If you did replace everything with sines and cosines, you could still obtain this answer of cosecant squared, but it would be a little bit more work than what it was here. So knowing some of these other identities, particularly the ones involving tangents and cotangents, secants and cosecants, and their squares, is often helpful in finding an efficient route to our simplification.